Good morning, afternoon, and evening, everyone. My name is Rob Meyer. I run Outbound Product Management here at GridGain. Before we get started, I wanted to make sure you know your way around the screen. So if you can hear me, please try to raise your hand in the GoToWebinar control panel. It's in the upper right-hand side. You should see a little hand icon. You should be able to click on it. Perfect. I see some hands going up. All right, so if you cannot hear me, we will have some technical assistance. Elisa's going to be helping out. You can post your questions in the question tab. Just open it up and start typing. Elisa may answer some technical questions for you, meaning technical questions about the webinar. She's going to save the questions for me towards the end, and I'll go back and look and see what kinds of questions you may have. Elisa will probably interrupt me if something's going terribly wrong, so feel free to speak up on that as well. Okay, so for those of you who don't know, Apache Ignite or GridGain, back in 2014, GridGain donated the code to the Apache Ignite project, which is all about in-memory computing. There are several thousand companies using Ignite. There's several hundred that we as a company, as GridGain, work with, and we not only give them services and support for Ignite, we give them some additional tools for taking Ignite into production. It's deployment, monitoring, security, rolling upgrades, all kinds of replication and other things for disaster recovery and multi-data center support. But in the process, we get to see all kinds of best practices, what works for different types of deployments and what doesn't. And so we felt it was important to get those best practices out there, starting with how do you build a foundation for implementing in-memory computing, the people, processes, and technologies, and then project by project work through some of the tips and tricks and explain what some of the best practices have been. So we're trying to get those projects out there, one webinar at a time, and then you can click on them in any order. You decide based on your project outline, how you think you need to implement, you go back and refer to these webinars, one webinar at a time. Now, that said, we actually decided to change the order a little bit. We realized there were a lot of questions coming up about real-time analytics. We thought maybe we'd be covering that a little bit later. Maybe we'd cover something like bridging to the cloud first. But we realized we needed to bring it up front. It's been coming up a lot recently, in part because we've seen accounts, we've seen Ignite customers and GridGain customers trying to add speed and scale to their existing analytics infrastructure, in particular Hadoop, data lakes, and Hive, and then realizing they made some mistakes in their initial choices. So really, one of the big goals of this webinar is to try to help others avoid those initial mistakes and get the initial architecture right early on. What I mean by that is if you get nothing else out of the webinar, it's this, that digital business is really about improving the customer experience. And the only way to improve the customer experience is not just to have APIs. It's not like you can build APIs and they will come, or that APIs magically open up parts of your IT infrastructure that people magically want to use. They're used not just for partners, but they're used as the back end for customers and for how customers interact with you and what their end customer experience generally is. And in order to make that experience better, which is the goal of digital business, you need to be able to watch each and every step of that experience and somehow analyze it, streamline it, automate it, and improve it. And it turns out that you cannot do that with ETL. You can't do it with data warehouses or Hadoop-based data lakes or even separate streaming architectures like operational intelligence. And the reason is it all takes too long to get an answer back to the customer in time within an interaction to make a difference. And that's the problem. So what a lot of the Ignite customers realize that are using this within the context of API management and then going forward is that the only real-time architecture for digital business, the only way to improve real-time analytics and automation and implement it is with some combination of streaming and in-memory computing that implements what Gartner calls Hybrid Transactional Analytical Processing, or HTAP. And it needs to be layered on top of your existing analytics the right way. And so what we're going to do is go through the details and focus on the best practices of how that architecture works and what are some of the tips and tricks you should be thinking about to be successful there. But first, I want to make sure we all agree on the goal. We all get why digital business is about improving the customer experience and why it's so important. So I'm going to refer back a little bit to some of the foundational stats. And you can go back to that webinar if you want and learn more about it. But basically, if you look at the numbers from a business perspective, digital business is about improving the customer experience. The reason we go to Amazon is because it's faster and simpler to buy from Amazon. It's a better experience. That's how they became a $200+ billion business and $1 trillion company in market cap within what, about 20 years. There have been a lot of studies done on this. HBS did one. This is the HBS study. McKinsey, MIT, and Price Waterhouse did a great one back in 2014. But here's the summary. Those companies, when they slice up companies as the top 25 and slice it up into quartiles and compare the bottom and the top 25% of companies, those who are adopting digital business better, they have all kinds of criteria for this, are about 50% more profitable. They're better in gross margins and earnings compared to the laggards. This actually dramatically underestimates the impact of digital business and what's really going on here. So what we went through in the foundation webinar was why this works. So here's the summary. Customers want that more personalized, more convenient experience, and there are two big wins when you give them that, when you figure out how to serve them better. The first is if you keep a customer, if you make them loyal, they'll spend somewhere between 2/3 to actually to 2 times more annually, and you'll get roughly 10x more revenues out of them, out of the lifetime of them being a customer. And if you look at the data, and there's some links here at the bottom, about 20% of the customer base in retail generates 80% of all the forward-looking revenues of a retail company. So first, if you can just keep the loyal customers somehow, you create this core base. Now, Amazon does this pretty well. But even what Amazon doesn't do as well, and this is what I mean by underestimating, is that no one's really executing very well on the second big win, which is recovering customers when they have a bad experience. And a bad experience is brutal to a business. It is the biggest reason for attrition. We don't leave a company or abandon a vendor because of a bad product. We only do that maybe 15% of the time. 2/3 of us leave because of poor service. 90+% of the time, we don't tell them why we're leaving or that we're leaving. But if you find, only about 4% actually tell us as a customer. But if you find people having a bad experience and you fix their issues, 70% of the time they stay and they become a loyal customer. So here's the big payoff. If you can even just fix customer retention rates by 5%, keep 5% of those 25%, really a fifth of those 25% that you're losing, and keep your loyal customers, over a 5 to 10 year period, you can double that loyal base, which means you can more than double your profits. That is bigger than the entire IT budget. And that's why this is so important. So if you can track their experience, figure out what's going well, what to promote to them, cross-sell, but also when to jump in and fix their problem. That is the biggest payoff in most businesses today. And that's why everybody's focused on this. So that's the business reason. The problem is ETL does not, if you have analytics that are based on extract, transform, and load, there's no way to get that kind of real-time visibility. You're always looking backwards into what already happened. So the reason we ended up in this situation is that it used to be you'd build operational apps to support a point problem, ERP, CRM, customer support, whatever it was. You would first implement that application, and that application ignored company analytics. It wasn't part of their problem. And it was worse than that in a way, because when you solved the point problem, you only had part of the data of the company and a part of the data about the customer inside that app. So not only could they not support analytical workloads, they only had a piece of the puzzle. So you had to grab that data out of the app without putting a heavy load on it. That's where technologies like change data capture came out, and they made it very efficient. They brought it down to about 1 to 5% of the total load on an app might be from change data capture. You then have to take all the data that's in there, some of it which might be dirty because it wasn't being validated all the time, and then somehow transform it. So extract it, transform it, and in the process of transforming it, do any cleansing and merging that you needed to do, and then load it into a warehouse. So you really had to piece back together all the data from different sources and create this, sometimes a little bit of a Frankenstein of an image of the view of the business. Now, ideally, over time, companies implemented data quality well enough to cleanse the data in the source. Ideally, there was point of entry validation of data that was using data quality rules in real time. And ideally, and this is usually the last step in a company, they'd be implementing master data management to make sure the master data in each of the applications was consistent. If it changed in one, that there was a process for changing it in the others to make sure that the merging would happen seamlessly across apps, and it would reduce errors in transactions as well. Because every time an error would happen in a transaction, it would pop up. Some person would have to handle it, manually fix it, and then put it back in the system. This all worked before because the data could be stale. You could actually rely just on historical analytics. You didn't need to fix it in real time as things were happening because people were in the process. With digital business, when you are trying to deliver a simpler, faster, better process, you are automating a lot of things. You're cutting a lot of steps out of the process. The more real-time you become, the less time you have to fix data errors and other things like that. It must be clean right up front, and that's the challenge. So not only does the data need to be clean so it can pass through, but if you're watching a customer and you go out and ask an ETL-based analytics system to, hey, what's going on with this customer? Do I need to do something? You not only have to wait for all the data to flow through the ETL process into the warehouse, you then have to wait for the warehouse to do all the computing, and that takes time. It takes too much time. It takes too long to be able to do anything within the process within that interaction. The only way to fix this, to be able to do the analysis and to automate within a process, is actually to change the apps. And that's the reality. Now, you may remember Lambda architectures. They started about 15 years ago. They're actually a lot older than we all give it credit for. We've actually been doing Lambda for decades. Really, Lambda just means that you're going to merge any kind of real-time analytics that you're doing with any kind of historical or more batch-based data. It's not just that you have a real-time stream and then eventually you're going to have a batch-based stream that's more accurate. Generally, we try to make the real-time stream more accurate as well. It's that you have multiple types of analytics, real-time and batch, so you have to merge and make consistent to have a good view of the business. So we're not going to be able to replace existing analytics infrastructure with new real-time analytics. That's not how this works. You have to assume that both exist, that both are going to feed each other, and they have to be integrated. Any real-time analytics depends on historical data. It does as a threshold. You have to figure out when things are going wrong, and you base that on thresholds that are based on historical data performance. Any real-time feeds will eventually need to feed into historical systems. So they have to be integrated both ways. And if you're popping up a real-time report, comparing it to a historical report, then you need to look consistent. Otherwise, bad things happen. So the first best practice here is you really need to architect for both, and both working together. You can't just architect for one or the other. Traditionally, if you think about analytics, it's not really just about analytics. It's about the type and the freshness, or the real-time nature of the data. How real-time is it? It's about the type of analytics you're performing, and it's the action you take off of it. And traditional analytics has usually been ETL-based, somewhat fresh, somewhat stale data being used for reporting, traditional account-based reporting, internal management reporting, operations reporting, and ad hoc. And the only reason ad hoc is acceptable is because it's people that are taking the action. They're trying to analyze and look for new patterns inside structured data. They know the data they're looking at, but they're trying to figure out, is there a new pattern that I missed? Okay. Now, we've tried to head towards real-time analytics in many ways. One of them was throwing hardware at the wrong architecture, trying to accelerate an ETL-based analytics architecture with specialized hardware like Teradata. Even if you do not care about the cost of that, which ended up being sometimes $100,000 a terabyte for your real-time warehouse. The other problem was that the data still needed to move out of the apps through ETL or ELT in the case of Teradata-like architecture. And then the answers still had to go back to the apps as part of the automation. And that took too long. Others have implemented point streaming solutions. You may remember business activity monitoring from the 2000s. You may remember operational intelligence that business groups may have implemented over the last decade, which involved a combination of streaming and then real-time aggregation of the streams and real-time dashboarding and monitoring. Some of them may have even involved automation. So things like complex event processing or simple rules engines, or some form of what people called streaming analytics. There have been a bunch of them. Some have even started implementing machine or deep learning. Machine learning basically meaning statistics, and deep learning meaning self-learning, or the machine actually learning on its own. So all of these have been going on, but the problem is they've all been separate from the applications. So there's always a delay. And even though that works when a delay is acceptable, when it needs to be real-time enough, you not only have the fact that you have these point solutions that may be out of sync with each other, they may be having different streams and different logic. There's no way they can operate fast enough to support the app in process. So what we've been seeing in the Ignite community with Ignite, with Spark, with Kafka, is that the only real way to do real-time analytics and operation is to build this new real-time architecture that's embedded in, that's integrated in, and part of a stream of a series of new real-time apps and APIs. So the data clearly needs to be streaming and be real-time. So you see traditional JMS, you see Kafka, a combination of that as your streams. You might see MQTT coming off of an IoT, a set of devices in the Internet of Things. Most of the analytics would be or should be triggered by streaming data. So any monitoring in dashboards is typically displays of streams and updates or aggregate metrics against those streams. They tend to be a combination of the real time being thresholded by historical data coming from the existing analytics. There's generally no ad hoc. It's not that you're slicing and dicing when you're becoming real time, because again, you need a person to do that. You are generally, you know what your structure is, you know the analytics you're performing, and you know the actions you're going to take off of it. Even if you're doing machine and deep learning, you're training your model in advance out of band of the actual execution against the stream, and your current model is executing against the stream. You're not doing ad hoc. You've somehow automated the types of analytics and the actions you're going to take. And you're probably, for the real-time stuff, not having multiple network hops in between either. And this is the premise of HTAP, of running the analytics in place against the same data and the automation, the same data that is used for the operational or transactional app. We're going to cover this later in detail, how this actually works. Okay. So as you add new layers and channels through APIs or through web apps, you tend to start to add analytics over time. And in many cases, these analytics are added stream to historical ETL, because that's what exists, that's what people are used to, and they're really trying to add new data sources to their historical analytics. The problem is doing this direct path to the historical analytics is a little short-sighted, because eventually you're going to want to use that data for real-time analytics as well. Generally, what makes sense is you're going to try to build up real-time streams that can then feed those analytics, those historical analytics today, but then be used for real-time analytics tomorrow. Otherwise, you're going to rewrite your integration. So first, you may be adding in-memory computing to add speed and scale to your existing apps, the custom apps on the right, or the APIs in the middle. You may move a node to co-locate it with each API in your Docker Kubernetes infrastructure, deploy them together as a common container, have them scale with the APIs, and cache the data that is the structure needed for the API in the right format within each node. That's most typically how it's used. It brings the data as close to the API as possible, because that is the only way to make an API responsive enough to be sub-second for a customer every time. Or you'd be using it as a bridge to cloud to make sure that any SaaS applications have the data from the on-premise apps as they need it, not have to bounce through a firewall, bounce through several layers of middleware and APIs, back to the custom apps, come back, merge it, and somehow put it in the staging area, or eventually deposit it to a place where the SaaS app can consume it. That's just too long, it's too slow. So you'll see in memory computing it plugged into these various places. Those in-memory computing proxies or nodes or layers, they become a new access point. They're a great integration point for adding analytics, because a lot of these in-memory computing technologies, or at least a few of them, can support running transactions or other types of transactions or other types of analytics against that same data. They don't just unlock the data for new types of APIs, for example. They actually unlock it for running any kind of compute against it, including analytics or machine or deep learning. So they also happen to be event-driven. That's just the way they've evolved. So something like Ignite, for example, Apache Ignite can fire off events, receive events, run logic out of band during transactions, and calculate things or trigger actions to happen during transactions. So most typically, you might see Kafka and newer implementations. We see a lot of JMS as well. So in parallel, over time, a lot of these companies have been building a streaming pipeline. You might call it a stream. I've heard some other folks call it a river. I like rivers. But I'm going to use the term stream for this webinar. So you might build streams, which are basically different types of events flowing on a common pipeline, accessible by everyone at any time. So that's more often than not, we're seeing a lot of Kafka, but you may have an ESB integrating Kafka with JMS to expand how many different events and messages you can get access to. And then over time, they're adding new processes, new processing engines. And what we'll talk about is how do you architect to make sure you can add these processing engines incrementally over time. There are some best practices there as well. But these are all kinds of engines, from IoT ingestion, maybe a customer-facing HTAP-based application, like something doing profiling or personalization or pricing calculations. And they're all taking in events from these streams and then firing off new events. They may be performing real-time analytics, like monitoring, like they may have implemented the equivalent of BAM or operational intelligence on the stream for operations. They may be doing advanced compute grid-based calculations, high-performance computing like risk analytics or fraud detection. And they may be using that same kind of technology for doing some machine or deep learning. The point is now they have two streams. They have the existing ETL-based analytics, an ETL pipeline, and they have the new real-time streaming. And what you have to do is figure out how do you make these two work together. And typically what ends up happening is they build an in-memory computing mediation layer. Now, I'm talking about the Ignite community. So you would expect that they'd be building an in-memory computing mediation layer in the middle. But this is how it works for the applications. There are three types of integration that I've seen across these deployments within this in-memory computing mediation layer or around it. The first one is they just have APIs for each application that's built on top of the in-memory computing that provides direct access to the real-time streams and to the historical apps. And it's the app that merges it. The app is actually a cache of sorts that combines historical and real-time. So it may be streaming in through Kafka or JMS and being processed continuously as it's streaming in. It may then be combined with a batch or a pull SQL or a Hadoop call, an HDFS call or something that pulls the batch data in, and this gets combined. That's one approach. Here, the data is being processed in the middle in an in-memory computing layer outside of the stream, outside of Hadoop, in an engine, if you will. Then there's also the out-of-band synchronization. The app is processing data and pulls it as it needs it sometimes. Other things are data-driven. If something changes in real time, data gets aggregated to a certain point in time, it should be pushed down into the historical layer. If historical data changes in batch calculations, the new historical threshold should be pushed up to the real-time layer. So it's bidirectional. And often with data lakes, you'll see some kind of, they might call it a Hadoop connector or a data lake connector that does this combination of bidirectional synchronization based on changes triggered by changes in each layer, or maybe even scheduling, okay? So you'll typically see some kind of Hadoop layer. The second one is some kind of federated query layer. In this case, I labeled it as Spark because that is actually the cheapest, most open source approach. You can use Spark SQL as a federated query across Hive, across standard SQL sources. It's pretty straightforward. So that's what we do at GridGain. But there are other approaches. You may already have a federated layer built up. Here, the application may be relying on a federated query to pull data in that it doesn't want to cache locally. It just doesn't make economical sense, or it's just faster to implement it right now using a federated query. And so they do it initially with a federated query, or they keep it that way. These three approaches, where you might use in-memory computing in the middle, you might use a dupe connector to make sure that data can be analyzed in the top, on the streams, or in the bottom in the batch pipeline, or be pulled using federated queries from both sides, from the top and the bottom. You're going to use all three of these. So you need to architect to support all three. You need to expect it. And I guarantee you, over time, you will see that you'll want to use all three of these. So you need to architect to support all three of these over time. So you're going to need to build this new real-time layer. That's clear. If you don't see the need yet, you really should be going out and asking those questions. Why aren't we going towards real-time? Because it's the only way to succeed if you're really doing digital business right. And digital business is a make or break initiative for a company. You either do it right or you're at risk of going extinct. So you need to build that new real-time layer that supports transactions and analytics and automation in the same place. It's going to be a combination of streaming and some kind of in-memory computing to support that. But your ETL is going to continue to operate as is. You're not replacing it. Your real-time might become a feed into it and vice versa. But understand you're going to do both. If you let these one-off operational intelligence or BAM or other real-time initiatives operate on their own without building your common streams, you're going to have an integration nightmare down the road. So at least make sure you control your messaging and event namespace, your core message bus, and your message architecture. That will help keep things a lot cleaner. And then there are several ways to integrate across these two layers. We talked about the three. You're going to use all three, so plan for it. The second practice is move towards integrated Lambda. And you might ask, so how integrated will batch and real-time be? And the answer is better over time, because you're going to need to push yourself to continuously get better. One example of this is Wellington Management, and they've presented a few times at the In-Memory Computing Summit, which we host for multiple vendors and companies. So you can go look at those sessions. I included the link at the bottom. But Wellington, who's one of the top 20 global asset management firms, they've got about $1 trillion under management. They use the Lambda architecture that they've deployed entirely in AWS. So their challenge was they had so much exploding sizes of financial data, they needed to scale horizontally. The 2008 financial crisis put on a whole new set of financial regulations that required so much more calculations that they simply could not adhere to the financial regulatory requirements anymore. And there were so many new things, new products and asset classes they wanted to introduce to grow, that they needed to be able to do all these calculations even faster and release new asset classes faster. So they built a new investment book of record in memory, and it's actually two investment book of records. There is a current IBOR, or investment book of record, on GridGain that sits on top of Oracle RAC as its backup store. And there's a historical IBOR, which also uses GridGain sort of as that in-memory mediation layer that sits on top of Elastic MapReduce and S3. That's their data lake. Within GridGain, they can merge the two for all their calculations, which is their risk analytics, their settlement, their portfolio management, and compliance. The current IBOR holds all the current data in RAM. And it also holds only the most frequently used historical data in RAM. The rest is actually down in disk. You need to aggregate, you then aggregate the current over time and load it into historical. So there has to be that level of integration. Okay. So this is a very typical architecture. You're going to see they got about a 10x improvement in their analytics calculations, and they got their horizontal scalability by doing this architecture. You're going to see a combination of that real-time and historical. even in some of these newer architectures like what Wellington produced. So, the second best practice. Wellington mostly built their Lambda architecture from the ground up. In general, you're going to start from with an existing layer, an existing ETL batch layer. They're not integrated, but over time, as you add new sources, first, make sure the real-time layer is the new source of the truth, and meaning make sure you're streaming into the real-time layer and then streaming from there into the batch, so that you set yourself up for being able to move to a consistent real-time and batch architecture down the road, that the logic's going to be the same. So second, work up front on feeding any aggregates in the real-time layer into the historical layer. Clean up as you can. Don't just let two sets of logic continue to exist in the batch and in the real-time, because you can end up with errors with data not matching. Make sure you're pulling your thresholds from the historical layer and you're doing your calculations there. That's going to make you consistent. And then I would actually recommend designing access layers for your applications, both for the real-time and the batch, as layers that allow you to change the batch and the real-time architectures over time. Insulate your applications from any changes in the real-time streaming or the batch layers. So implement that mediation layer up front. And then start to use in-memory computing as an intermediary layer to support the faster computing, the low latency, high scale computing, not just as a transaction layer. So plug in-memory computing when you can into your APIs, into your other places, because then you can start to, it gives you an inroad into easily adding automation and analytics down the road into those applications. The third best practice we've seen is build a new data stream, a new real-time data stream, one engine at a time. And what that really means is general purpose messaging is very different from point to point. So make sure you understand that. If you implement messaging right, you can have a message or an event where any task that you put on this bus, anything from an app down to a microservice, can subscribe to an event and fire off a new one. This makes each task or microservice or app very loosely coupled to the other ones. It gives you a lot of flexibility to change individual microservices. It gives you a lot of scalability too. This is why people usually recommend asynchronous for microservices and talk about messaging for microservices. There are many telecommunications and media companies that have been reinventing their infrastructure, building things like voice over IP and other services over IP, as IP has become pervasive. And they're a great proof point for an event-driven architecture with scale and speed. If you'd asked me 10 years ago whether your standard IT vendor would get into the OSS or the switching layers, I would have been very skeptical, having looked at it a few times. But now that's a lot more common. And Bandwidth Communications was a great example of this, who basically were building new data streams on Kafka and Ignite. In their case, they had one specific challenge with their streams. They wanted to create a unified call detail record and all the information about that call and the customer that they could stream down to other applications that they wanted to build, like a 911 application where the police needed information about that customer, or a unified billing system. The streaming architecture made this really simple. You just build a new app or engine that takes the inbound messages from several places, subscribes to them, and then aggregates and publishes in a unified call detail record and spits it out as a new event. This is what we mean by additional flexibility when the streaming architecture is done right. So the third best practice is, when I say build one engine at a time, I really mean put in place an architecture that allows you to build incrementally one engine or app at a time. And so the foundation for this is, for the apps and analytics, is HTAP. And it requires in-memory computing, but remember, the main point from the beginning that we said, if you remember nothing else, remember this: make sure you build in-process real-time HTAP on a combination of in-memory computing and streaming, and layer it on top of your existing systems. It should be designed, the streaming should be designed as loosely coupled, based on events, on a namespace. And in order to be loosely coupled, you have to map out how you're going to build this all, and then build it incrementally on this architecture. So you need to plan ahead. You need to group projects together to make sure what combinations of events and messaging and engines you're going to build across a couple projects together that allow you to build one project, get a return on that project, and then reuse what you just built in a future project to get a return in those projects as well. Just like APIs, you're going to have to group projects together on a roadmap and plan ahead and know what you're going to reuse from previous projects, the data, the APIs, or the engines, because that's actually, unless you have a CEO writing a check for an unlimited amount of money and gives you an unlimited amount of support, you have to prove you're making progress. So you have to look ahead. And then the final thing I'd say is design your engines as microservices, because this is your opportunity to make sure you're designing a more flexible modular architecture. And these kinds of engines, when you break it down to microservices, they're basically event-driven APIs, which is really what APIs should be. So you can set yourself up for the right long-term architecture for being event-driven if you do this right. Okay. Okay. Best practice number 4. Let's talk about HTAP and what it really means on how to architect it. So for those of you who aren't familiar with this whole concept, in traditional extract, transform, and load, or ETL pipelines, we would offload the analytics from each individual app we built using something like a file dump or CDC for real time. We made that really efficient. We made it, maybe a minimal 1 to 5% load on the app over time. We figured out how to do that. And when real time wasn't needed, when we could wait for the analytics, that was okay. But unfortunately, that now all needs to change for digital business types of apps, new channels, or the Internet of Things, where we're automating and streamlining processes. And this is where Gartner came up with the term Hybrid Transactional Analytical Processing, or HTAP. It's the ability to run analytics in place in the app against the same data that the transactional or operational apps are using. 451 research calls it HOAP, which is Hybrid Operational Analytical Processing. It is really more about operations or interactions, and I actually like this term better, and even Gartner has said, kudos to 451 for inventing a different term. So whatever you call it, it's needed. It's needed not just as being able to run real-time analytics. Sometimes it's needed for what we call in-process HTAP, or running the real-time analytics and automation within a transaction so fast that you can actually change what the transaction is going to do. And that's how you streamline a process. That's how you figure out if a customer needs help, and you recover and you retain them. The only way, and you can go through this logic and think about it, to do HTAP or HOAP fast enough and scale it is using in-memory computing. Now, I should say by using what we call the definition of in-memory computing. If you want speed, if you really want to get the fastest performance, you need to put the data with the application in local memory with the code, because that's the fastest possible thing you can do. That's the lowest possible latency. It cuts out all network hops. It cuts out fetches from disk. You need to have it already there in RAM up against the code. If you want true linear unlimited scale, and scaling vertically is not enough, The only way to scale at that point is to partition your data and co-locate data with code using what some people call a shared nothing architecture, where the data and the code doesn't really need to move. The data and the code are there, and maybe you move the code, you distribute the code, but you don't distribute the data because it's so big. Because the network is the first bottleneck you hit in these distributed architectures. And you can't wait for the code can't wait for the data to travel over the network. So I think Hadoop proved out that this kind of architecture can work first. They created this shared nothing architecture. You had Cassandra and others start to use it. And then folks like Ignite have proved that it works for SQL databases and compute grids. In fact, that's why Ignite is used. It's used for in-memory computing for storing and managing SQL data and for running all kinds of general purpose computing in a grid. Once you have this architecture, you can combine transactions and analytics. You can add any kind of code up against the data. For example, you can embed a node from a cluster within an API in a Docker container. You can load the data needed by the API, and then you can execute anything against that data within that node or across nodes. In the case of cluster data like this, you may split up the data to run the analytics efficiently. In that case, only the result gets sent back to that API to understand, to cross-promote something within a transaction, or to present something to the customer as a reward because they've been having a bad experience, or to help them fix their experience. When you send the results, not the raw data, that becomes fast enough, and that's what people have realized. HomeAway, which is part of Expedia, it's VRBO. If you've ever used vacation rental by owner, they realized this pretty early on. They were performing somewhere around 500,000 pricing calculations. This was a few years ago, so they're probably well over 500,000 pricing calculations per second now at peak times. These were initially micro batches of 200 calculations, and there were 2,300 batches at a time. So something like 4,600, 460,000 calculations. In order to do those pricing calculations that you see on your screen when you do the search, they needed to move 110 gigabytes of pricing data per second to the code from some kind of data store. And they needed to show your screen every time in less than a second, or you were probably going to go away. There was no way to move 110 gigabytes of pricing data over the network. A typical network that we're on right now moves a gigabyte per second in your corporate backbone, if you're lucky, with no collisions. So that didn't seem possible for HomeAway. What they did was co-locate the processing with the pricing data. They pushed the calculations down to the data. And that's how they got sub-second response times every time, even at peak loads, and got horizontal scale. This kind of pricing or personalization is exactly what HTAP is all about and what it first gets used for. But when you use in-memory computing like this as a compute grid or as a service grid to host logic for APIs as well, you generally have a general purpose compute grid. So what you want to look for are support for the languages that you're going to use for your transactions and your apps and your APIs, as well as your analytics and your other workloads. So you definitely need support for SQL. It's strange how many in-memory data grids and caches have not supported SQL in the past, but it's the #2 programming language after JavaScript. You're going to need to use it. You're going to need other kinds of code as well, because you're going to run various kinds of logic against your data. That could be Java, .NET, C++, whatever. So you're going to want to support other types of compute workloads as well. You're also going to have to look ahead far enough and think about what other kinds of workloads are you going to run. There are a few in-memory computing technologies like Ignite that have implemented continuous learning on top of their compute grids. Spark has some streaming support as well for machine and deep learning, and Spark and Ignite work really well together in those kinds of use cases. Make sure you map out your machine and deep learning architecture now and work towards continuous learning. This is the ability to be able to incrementally test and train your model over time. As people, if you think about what we do as people, whenever we have a problem with how we're making decisions and need to adapt, we don't just say, sorry, I'm going to take a training break, read a ton of data over a few hours, retrain our brains, and then come back to processing. We do it on the fly. And so we need machine learning to do that. But unfortunately, machine learning and deep learning in a lot of independent infrastructure does not do that today. You might have to load terabytes of data, which takes hours, into specialized infrastructure, then train the model, which might take hours in brute force training, before you can change your model, which you might have tested as being out of bounds and not working properly. Continuous learning, whether it's in Ignite, and this is how Ignite works, or in something else, means you can execute a current model against a stream, in parallel be running tests against that current model, and whenever it goes out of bounds, kick off an incremental retraining, all against the same stream. And you might be doing the retraining out of band and continuously updating the model. Ignite even has built-in splitting at this point because people wanted splitting of the data for testing and training. And so all of this can be done incrementally as the stream is coming in. That means there's no ETL for training the data, so that time's cut out. The algorithms can run in place and incrementally. They're fully distributed, the initial ones that are part of the Ignite project. And because Ignite is stream native, it can do this all incrementally. So think about your loads. Think about your HTAP as an architecture and how you use a combination of in-memory computing and streaming to implement what you need for your workloads today and tomorrow. Don't just buy in-memory computing to offload reads for an existing app. Buy in-memory computing or implement it, something like Ignite, to support the analytics and the automation down the road as well. Don't paint yourself into a corner. I have two more best practices. The first one is embrace data lakes and plan to move in real time. I'll give you an example. There was a leading public health agency. They administer health programs for many citizens in a particular country. They were having problems with fraud, not too surprising. Dead people submitting claims, for example. They were trying to analyze that data in Hadoop, but were struggling with the Hive performance, like a lot of other people who implemented Hadoop. They expected a silver bullet of getting really fast SQL on top of unstructured data. So their current architecture, by the way, was to grab the data from a web app through DB2, push it into Hortonworks through ETL. They decided to, and the reports were just taking days and days and days. So they decided to accelerate those reports by moving the data into Ignite, Apache Ignite, and GridGain, and got it down to really fast performance. There were a few reasons they chose Ignite for this. They needed SQL. Remember, they were trying to accelerate Hive, which is SQL, but they realized just accelerating on top of Hive wasn't going to work. So they actually would bulk load the data or stream it in from Hortonworks into Ignite. And then they chose it because they weren't just running their current analytics and using SQL. They actually wanted to write code, eventually adopt machine and deep learning, and Ignite gave them all of that. But the final reason was they realized they needed to move to real time. And if you think about it, the best time to stop fraud is not after the fact using historical analytics. The best time is when it's actually being committed on the website. So they knew they needed to move towards HTAP and streaming. This gave them an intermediate approach. So make sure you embrace the data lake because it's the current version of the truth. And accelerating SQL is a common use case. The investment that's been made in the data lake in terms of cleaning it up, data quality and consistency, it's a big investment. So reuse it for now and then plan over time on how you're going to implement that in real time. don't generally try Hive acceleration or federated queries. It's just not as fast. You're gonna end up with a data mart or synchronized in-memory and Hadoop layer. That just generally works better. And then look ahead and think about how you're going to implement this in a real-time version of this upstream towards the live streams, towards the website to have a faster impact. The final best practices is implementing real-time data governance now. I'm going to fly through this a little bit, but let me explain it this way. You're going to use all kinds of tools, all kinds of best practices in integration to implement real-time business. It's not just data integration, it's not just business process management or SOA or API management or analytics, it's all of them. I've worked on all of these at this point, and I've seen that most of them get used this way. So if you're going to streamline a process, you're going to have to think about process management, data management and governance. You're going to have to think about your event architecture, all of this. And so beyond just your foundation, which we've been talking about, which is a combination of in-memory computing for APIs or for analytics or for automation, you have to actually think about how you're managing and streamlining the process, how you're tracking the experience of the customer, and possibly upfront, first among all of those is how are you cleaning your data? How are you making it consistent? Because when dirty data comes in real time, it goes right in and causes damage. You need to actually be able to have enough data integration, meaning data integration, data quality, and even master data management up front to make sure it's clean data in and clean data out. So if you go back and look at, just quickly, if you go back and look at the ING example early on when we were talking about API management or even earlier, you'll realize as you go through Lieven's presentation at the in-memory computing summit, ING implemented a lot of things up front, not just an API. They actually implemented data validation up front for the customer experience APIs, the ICEP APIs that were exposed to the customer. And if you look really closely, you'll see they implemented validation. And if you go further and you look back at some of his other slides, you realize up front they were already looking at how they implement master data management as a cache. Master data as a cache for point of validation services where, just like what we do with Amazon, you enter in you buy your stuff, and then it prompts you, is this the address you want to use? And you either say yes or you correct it. That's point of validation right there. And they'll check on the address. They'll do a search, they'll make sure it's a valid address, and they'll tell you if it's not, wrong zip code or something else. And they'll tell you your master data, who you are, everything they know about you up front. All of those APIs have to exist to make this architecture work properly. And ING implemented this. So make sure you look at data governance up front because it's critical to real-time analytics and operations right now. You're going to have to think about your data quality and even your master data. I remember walking into one big bank, the first project they were doing as part of this huge treasury services in-memory computing implementation. They were actually implementing a master data master cache up front. So think about how you're going to do that, how you're going to implement your data validation, the port of entry, what are those APIs looking like, and add it in with real-time data quality and master data management. Then make sure you're rolling this into data governance over time. Think of it this way. Traditional data governance can operate as is. Your new real-time data governance can just be for your new real-time apps. But over time, just like with traditional data governance, you're going to have to roll it in. That's pretty much everything I had. I want to make sure we have time for a couple questions. I'm going to flip up this resources slide so that you can, you know where to go to for more webinars like GridGain or the In-Memory Computing Summit. We also have the In-Memory Computing Summit coming up November 13th and 14th, so you should go register for that. It's in San Francisco, and there's another one going to come up in London next June. But if you want any of the previous recordings, they're all up there. There are white papers on these best practices and other topics up in GridGain in the Resource Center. There's some videos, and you can download as well. Remember, there's now the Community Edition, which is a hardened version of Ignite. We patch it more frequently. If you're an Ignite user, you can use that forever. Just go download it at gridgain.com. So with that, I'm going to go look at some questions. And so one of the questions was, could you get to memory processing? Hopefully I covered that, but let me know if we didn't. There are plenty of best practices webinars that are about taking Ignite into production or using different parts of Ignite. So please feel free to use those. There's a whole series up on gridgain.com. This recording will be made available after we'll send out this in probably a couple days. And then I'm going to answer one more question while the alarm's going off in the background, just to demonstrate this is actually a live webinar. There was another question about ad hocs. I want to be super clear on that. There are going to be times when you want to access real-time data and make it available for ad hoc. The thing is that even today, most in-memory computing technologies don't structure both for ad hoc and for structured analytics, computing and things like that. So you're generally still going to be doing ad hoc outside of HTAP. You're going to have huge data sets, you're going to have historical data sets, and you're going to do aggregates and pre-calcs. So generally your ad hoc is going to be happening either up against your data lake or a data mart. That's an OLAP-based analytics or columnar data mart that's pulling off your data lake. It's in your historical layer. It's generally not in your real-time streaming layer. And even the operational monitoring that you do, like operational intelligence, is going to be a combination of dashboards and reports, real-time reports and dashboards with drill downs, but they're structured drill downs. So those can all be indexed with an HTAP, and you can make those run really fast, faster than columnar. But in the case of ad hoc, you're still looking at the historical layer, and that's kind of the little nuance. So I hope this helped. If you want any more information, feel free to go here. We'll be putting together a white paper version of this and releasing it out, get a couple of blogs out talking about some of the specific topics here. And then probably the next webinar we'll cover here on best practices is bridging to the cloud. But in the meantime, there are plenty of good in-memory computing best practices, very technical sessions on moving Ignite into production. I think the next one is coming up next week on troubleshooting and hardening, so you might want to watch that one as well. So thank you very